Okay, now let's start chapter 8. Chapter 8 is about confidence intervals. What do you think when you hear confidence intervals? What? Confidence intervals. What do you think about when you hear, oh, this chapter is about confidence intervals? Okay, when you see a book from history and you say history of Russia after 1900, you know what the chapter is about, right? But when you see in a statistic book the name of the chapter, confidence intervals, you say, what are we going to cover in this chapter, right? Okay, confidence interval is a very easy concept. You want to know the interval where the real population parameter is located. Where the real population parameter, remember, we are getting a sample. And from that sample, I'm going to get what? Let's say X bar. And I want to know where is the interval where the real mu or the real population parameter is located. And that is basically confidence interval. Why confidence? Because we have to establish a confidence level. Confidence level, okay, is how sure we want to be about what we are saying. The higher the confidence level, of course, the higher or the wider the interval. Okay? But if I want to be completely sure or 100% sure, I have to say that the real population parameter is between negative infinite and positive infinite. Somewhere in between. I'm positive about that. Okay? But we don't do that. We have to establish a confidence level, let's say 95 or 90 or 80, that tells me that I'm 95% sure or 90% sure, depending on the confidence level that we choose, that the real population parameters is located in that particular interval. So that is why it's called confidence interval. Because we have a certain confidence about the interval where the population parameter is located. That's it. Okay, the confidence level. We have also one variable that is the significant level. And that is called alpha. Alpha. No, not A, not O, not S. It's alpha. It's a Greek letter, alpha. And alpha is equal to 1 minus confidence level, such that if the confidence level is 95 or 0.95, my alpha is equal to what? 0.05. Okay? If my confidence level is 0.80, or 80% or 80% of the confidence level, my alpha is equal to 0.2 and so on. So alpha is equal to 1 minus my confidence level. Why we want to know that? Because alpha is the one that is going to guide us on what? On the real value of my z. And the z is what? The standard normal distribution. So confidence level is based on the fact that based on my X bar, okay, I have to establish a interval which is going to be how confident this interval is going to be, whatever confidence level I establish. And what is alpha? The alpha are the tails. The yellow, the pink one. When I add these pink ones, I have alpha, so this is alpha divided by 2, and this is alpha divided by 2. So it really doesn't, it really depends. If your confidence level is 0.95, then my alpha is 0.05, and my alpha divided by 2 is what? 0.025. Alpha divided by 2. What is this one? 0.1. And so on. Okay? In this chapter, we're going to cover 3 types of confidence intervals. Okay? The first confidence interval that we are going to cover is the confidence interval for the mu when sigma is known. When I know the standard deviation of the population. The second one is the confidence interval for the mu, or for the population mean, when sigma is unknown, when we do not know the standard deviation of the population. And the third part is going to be the confidence interval for the proportion, for the population proportion. Okay? Those are the 3 sections that we are going to cover in this. So, remember, the confidence intervals are for the population parameters. It's either for the mu or for the pi, for the mean of the population or for the proportion of the population. Because we're going to base our answer or our inference based on a sample. That's it. The easiest one is the first one. Why? Because for this one, we are going to use the standard normal distribution. For this one, we're going to use the t distribution that we haven't covered, but we will cover. And for this one, we will use the standard normal distribution. That's it. Okay, so let's cover the confidence interval for the mu when sigma is known. Okay, when sigma of the population. So again, we are trying to establish a confidence interval for the population mean when I know the population standard deviation. Okay, so basically we have my x bar because we have a sample. And sigma of x bar is equal to what? To sigma over square root of n, right? Because we know sigma, so we know that one. And we need to establish this one. So, and this is the confidence level. And this is alpha. And this is alpha divided by 2. And this is alpha divided by 2. Okay? So my confidence interval is the lower limit of my confidence interval is equal to x bar minus z of alpha divided by 2 times sigma over square root of n. And the upper limit is equal to x bar plus c of alpha divided by 2 times sigma over square root of n. So we have the sample size, we have sigma, that is the standard deviation of the population, And so this is my confidence, my confidence interval. What is the confidence level? 1 minus alpha. Right? That's it. And the rest is like chicken recipe. I'm going to give you what?
Chicken soup?
Yep, chicken soup. Yep. I'm going to give you a table. Guys, put this table in your cheat sheet so you don't have to look for the tables. The confidence level, I give you 95. We usually use 95. Have you heard about if the elections, president elections would be today, the next president would be Mr. whatever it is, and they say that they are 95% sure? Well, they use this technique. Okay? Because most of the time, they use a 95% confidence level. Okay, confidence level 95, or 90, or 99, or 80. Okay? Guys, again, if you don't want to look at the Z tables, please write these in your cheat sheet. So, what is alpha? 0.05 over here, 0.1, 0.01, and 0.2. What is alpha divided by 2? Why we need alpha divided by 2? Because remember, we have two tails, and each tail is alpha divided by 2. What is alpha divided by 2? 0.025, 0.05, 0.005, 0.01. And what is Z of alpha divided by 2? For 0.025 is 1.96. For 0.05 is, for 90 is 1.645. For 99 is 2.575. And for 80 is 1.28. You can verify that either using your calculator or your standard normal distribution table. So let's do, like, for example, the 1.96. If I look over here for the 0.025, looking for the 0.025 over here, I'm going to find negative 1.96, right? It means that positive and negative, okay? I tell a positive over here because we have the negative part and the positive part. Why? Because we have the negative and the positive part, 1.96 and positive 1.96, and over here we have 0.95.
Is there a particular reason why you put the 99 where you put it? Or?
No, I don't have any reason.
Or you just put it to the top?
Yeah. Indeed, it has to, if we want to order this, first the 0.80, then the 0.90, then the 0.95, and then the 0.99. Okay, yeah, no, it doesn't have a particular, but you can have it in a particular, yeah.
Is alpha divided by 2 or 80 really 0.01?
Oh, yeah. Thank you. No, it's not. Yeah. Alpha divided by 2, this is alpha, and alpha divided by 2 is 0.1. Thank you. Okay? That's it. That's all about it. What is the confidence interval? You have the X bar, you have C of alpha divided by 2, you have sigma because it's part of the problem, and you have the sample size. That's it.